Saxon Advanced Mathematics, Lesson 67. Today we are in the topic of logarithms, and we're going to talk about anti-logs. Remember that the anti-log is this number. It's more easily referred to as the number, right? This is the base. This is the log or the exponent. You can call it either one. And this is the number or the anti-log. And just to rewrite this in exponential form, to keep our heads on straight, we say that 10 to the third power equals 1,000. Okay? So, there's the base. Right? It's the same information, just presented in a different format, but the anti-log is the number. And we're going to practice using the calculator to find anti-logs. And we have that problem of my phone being tied up being my video camera, and I can't use the buttons. What I'm going to do is, hopefully, on Thursday and Friday, I'm going to use my iPad to video, and then I'll have my phone available. So if you have any questions, we can use them. Here's the information I want to share with you on the buttons. I worked it out ahead of time when I had the phone in front of me. There are 3 different buttons that we're going to use in this lesson. 3 different keys, however you want to think of it, depending on the base. In all of these problems, we're going to choose the base, and then we're going to enter the exponent, and that will give us the anti-log or the number. Now, how do we know which one to use? It all depends on which base is being used in the problem. So we'll work that as we get to it. E is if we're using the natural log, and John will tell us that. 10 is if we're using the common log of 10, and John will tell us that. And then if it's not E or 10, then we have this button to handle all the random circumstances. To use these buttons, to use these two, we enter the x value first. So if I want 10 to the third, for example, I enter 3, and then I push this button, and then I hit equals. If I want the 7th power of e, I enter 7, then this button, then equals. So the x indicates that you enter the value before you hit the function key. Over here, if I want to say 2 to the 5th power, I hit 2, then I hit the function key, then I hit, what did I say, the power of 5? I hit this one. So when I have to enter 2 variables, I do x, then the function, then the y. Okay, so if you copy this down, and remember that these 3 buttons exist, it's when we have the base and the log, and we want to find the anti-log, or the number. So that's what we'll be doing in these problems. I'll give you a second to finish copying this. All right. So let's just look at these problems. They're pretty simple, you guys. It's just mostly learning to use those keys. If the base is 2, find the anti-log of 4.63. Okay. Anti-log, always substitute in your head number. This is the base. That means this must be the exponent or the log. So we can rethink this as 2 to the 4.63 power. That's exactly what we want to do. We estimate before we calculate. So we go, okay, 2 to the 4th is going to be smaller. That's 16. And 2 to the 5th is going to be a little bit bigger. That is, what, 32, right? So this number should be somewhere between 16 and 32 because 4.63 is between the 4 and the 5. So to solve this, so that's our estimate. Remember, we always estimate before we calculate. I just taught that lesson to the Algebra 2ers. the first time we talk about that. We've got a base of 2. So that means we're going to have to use this button. Oh, I'm sorry, up here is where our calculation is. Technically, I should say that my estimate is going to be between 16 and 32, right? It should be much higher than 16, but it's going to be less than 32. So technically, that's how I want to word my estimate. And that's my favorite kind of estimate, is where you give a range rather than just a specific target. Okay, so because our base is 2, we know that neither of these buttons will work. We're going to have to use this one. So it's 2, this function, 4.63 equals. And our actual number that we get is 27.46. No, 24.76. And is that between 16 and 32? Yeah, that's like halfway exactly, isn't it? Looks really good. Okay, so we're happy with that, and we're happy with our estimate here, even though I wrote it in kind of a crazy way. Next one. Use a calculator to find the antilog of 4.63 if the base is 10. We're finding the antilog. The base is 10. That means this has to be the log or exponent. Okay? The trickiest thing in these problems when we're starting out is just identifying, okay, which number is which. So that means what we're trying to find, base is 10. It's 4.63. Okay, this is a fun one to estimate, right? 10 to the 4th is going to be 1, 2, 3, 4. 10 to the 5th is going to be 100,000. So we would expect our low estimate at 10,000, our high estimate at 100,000. That's what I'm trying to say here. That says high and low. It looks like a 6 or a B. Sorry, it got crazy. Okay, now for this one, we've got a base of 10, so we can use this key, right? And we first enter the x value, which is the exponent, 4.63. Then we hit this one, then we hit equals, and we should get a value of 42,657.95. That's our actual. That's correct. I worked these all out before I started taping so I could be sure they were right. And 42 does indeed fit in between our high and low estimates. So we're happy with all of that. And there's just 2 more. And the next one is a really great tip that can be very helpful to you in your future life. Example 67.3. Use a calculator to find, oh no, it's the next one that it was what I was talking about. This one's basic. Use a calculator to find the base E antilog of 4.63. So that means this again is the log or the exponent. So this time what we're doing is we're saying E to the 4.63 power. Now this is a little bit tricky because what is E again? The next problem, and that's why I thought that this one should be first. Let me just tell you that rounded, the base of E is about 3. So we're going to do 3 to the 4th power and 3 to the 5th power, right, in between our exponent. We'll put our exponent in between. We'll use these as estimates. This is 81, and this is what, 243? So this is our estimate range. And then to do the actual, we've got a base of E, so again, we can use this one. We'll do 4.63, hit that button, and what we will get is 102.51. Is that in our range? Yes, it is. It's closer to the lower end of our range, which seems a little surprising because the 6.3 is higher to the 5. But as we're going to see in a minute, E is less than 3. So that explains why our estimates are a little bit higher than we might expect. But that's perfectly good. We're in the range. We're happy with it. This is the one I was saying, this would have been helpful for this problem. How does anyone remember what E is anyway? And it says, write the value of E to 5 decimal places. Well, how the heck are we supposed to remember what E is? Here's the trick. If you enter 1 as the exponent, right? So you would hit the 1 first, then this function key, then equals, that will give you the value of E. So you enter 1, and then you hit the function key, e to the 6, and then you have to do equals 2. And it will tell you that it is 2.71828. And this one you don't have to estimate. This is the actual. So if you ever need to know the value of E, just enter 1 as the exponent and use that key, and you'll get the number. This is how we knew to use the 3 here, right? If we would have done this problem first, this would have been easier. And you can see now, yeah, we did round up quite a bit, right? To get from 2.7 to 3. So that's why our estimates were a tiny bit on the low side, but it was fine. But that contributes to the wonkiness. One more. This is such a fast lesson, and it's, I mean, I hate to say it, but it's pretty easy. Evaluate antilog. Oh. Let me just show it to you. Evaluate antilog, tiny little e, minus 3.2. Okay, what that tells us is e is the base, and this is the exponent or log. So we enter it as e to the minus 3.2. Okay, so we have to do a little estimating around that. All right, that would be between e to the, or let's make it 3 again, 3 to the minus 3 and 3 to the minus 4. 3 to the minus 3 would be 1 over 3 cubed. It would be 1 over 27. This would be 1 over 81. And we need decimal numbers for those. I know 1 over 27 equals 0.037. I don't have this number handy. Let's use the calculator to run this through. Again, this time what you would do is you would enter 3.2 and then hit that positive negative key to flip the sign on that, and then e to the x, because we've got the base of e. And the number that you should get is 0.040762. Okay, and so that is quite close to this. It is a little bit bigger, right? So it's closer to 0. So we could calculate this as well and see if it came close. No, this is closer to 0. This is further away. So it should be in this range. All right, I don't have this value in it as a decimal in front of me. But once again, we find the base. We know that the other piece of information we're given is the exponent or the log. And then we use those and these 3 buttons to find the antilog or the number. Okay, that's the end of 67. Wasn't that cute and fun? Yay, goodbye.